Now we have a feel for objects, but to build all those fancy objects, we have to understand how to build classes. That's our job. As a developer, we build classes, and then we set up the code to build objects and tell the code what objects to build and how to the rules by which to build them and all that sort of stuff, in which is going to make our programs happen. So most of our life is going to be in how do we build classes, because classes become the factories by which the objects are built. And the way we define the classes defines the rules of how the objects get built. We get to tell them what data you store and what things you do and how do you get created, and all this functionality is done through the class. So it's not class-oriented program, it's object-oriented program, but we build the classes which build the objects. Important concept. And so in Java, the class is the most important architectural bit. All the source code we write gets put inside the class. The name of the class becomes the name of the file it gets stored inside of. And then when we compile that file, it gets turned into a .class file. That's how important this thing is. So considering this, the basics, how important it is, the basics of a class is very simple. I use the keyword class right here, public, says everybody can use this class, and then class is telling you I'm building a class, then I give it a name. And the name is the same thing that goes in the top box of that UML, looking back at that. So they have ties between the code we write and the UML that we build. And so we don't have to have the public modifier in all cases if you're just building one class in particular, but it's really important as we're going to build a lot of different classes. So we give it the make it public, tell us we're building a class, and give it a name, and then you have an open curly brackets and a closed curly brackets. That's the context for the class. That's a block in Java that builds everything that's inside of this block as part of this class. So it's really important to have them both. It's really important to have everything inside your class be contained by this open curly bracket and closed curly bracket. It's normally generated for you automatically when you build a class inside of the tools, but if you get it wrong, it'll give you a lot of compilation nightmares. So putting those in there and lining those up and making sure everything is clean between them helps you keep your code compiling and easier to understand everything that's going on. Now, as I mentioned, it's really important that the name of the file aligns to the name of the class you're trying to build. We saw this a little bit in some of the demos we've done up till now, but if you get those not aligning, your code won't compile and nothing will work. So whatever .java file you're in, someclass.java, the name of the class is to be someclass. If I don't like that name and I change it to myclass.java, well, the name of the class also must be myclass. So they always have to align whatever they are. It doesn't matter what they are per se, just that they align between the name of the class and the name of the file. Now, it's possible to put another class inside of a class as long as there's no modifier, but you can only have one public class per file. Now, why would you do this? There's not a lot of good reasons for it. People do it sometimes because they want a little code that's only used by here, and it's one way to hide it and protect it. It doesn't really actually protect it. It's sort of kind of hides it, but doesn't really protect it. And it certainly reduces the flexibility of your code later on, so it's just easier to create a separate file, a separate class, and it's pretty cheap to do that inside of most of our IDEs, Eclipse, NetBeans, whatever you're using, to just slap it out there and build another class. So in order to produce objects, I have to put in a class because the class tells me what the object's going to look like. It's telling me my relationships. It tells me my data. It tells me what methods it does. It gives me the constructor, which is the mechanism by which I build objects. And so all of this stuff is done in Java through the attributes, constructors, and methods. Going back to UML, again, the name of the class shows up in the top compartment up there. The attributes then show up in that middle compartment. That's the data that gets stored inside of there. And then constructors are what's used to build objects from this class. We'll learn more about those as we go, just a tiny little bit in this class, and you'll learn as we go. But the idea of a constructor is it's the same name as the class. So it's the name and the return type all at once. And then it allows you to pass in parameters to customize how your class is built. So, hey, I want to build a object to represent a product. Well, I can by default give it a price. So I know the price is set, and there's no way I have products that are free, which is the default 0, would be the default price if I don't set it right away. And then methods is also goes in that bottom box, which is all the stuff my class does, all the functionality that's given for that class. So when we draw these UML pictures that you're going to be asked to do, it does dictate the code we write and vice versa. The code we write dictates what should show up in these pictures. They do align. So we can use the drawings to mentally plot out, well, what do I think I want to build? And then use the code to write out what I was planning to do and then make sure the two of them align. So the layout of the class, the stuff that goes inside the class, doesn't really matter. You can put anything anywhere. Traditionally, attributes show up at the top, or sometimes the bottom, but they're not spread out all through the class. You want to kind of keep them all together so I can see what data is stored. Often, constructors are next, followed by public methods, followed by private methods. But again, all that can be mixed up, and these days when I build a class, I'll put all of my getters and setters at the bottom of the class because I don't really modify them, and they're something that can be generated, and I don't really need to do much with them, and so I get those out of the way. But this is the preferred layout, if you will, of a Java class. This is what people will expect to see. So one of the other things we can talk about is the package statement. The package statement and the imports must come before the class name. The package identifies the folder in which the class is residing if it's not the default folder. So the default folder is going to be like a source folder, SRC or however it's going to spell that out. And that's just where the program starts. We use packages to arrange the design of our class. So we can have, here's the things to do with checking out and shopping cart. There's the things to do with buying insurance. Here's the things to do with fantasy football. We can rearrange, arrange our code around these folder structures and then folders within folders as well. But if I put it in a folder, I have to know where to find it, and that's what the import statement does. It tells us, hey, this thing over here in this other folder, this other package, please go get it so I can use it. It just makes it available. So yes, I am declaring I wish to use the java.util. Whatever class, or the java.io. Whatever class, if you're doing file stuff or GUI stuff or whatever we happen to be doing at the time. And so within that is the only real rules for how classes must be structured. They must come first. The important thing to remember, though, is that everything that's inside the class is considered having membership of that class. So if it comes between that open curly bracket and the closed curly bracket, it's a class variable, a member variable, or an attribute. Methods, constructors, later on you might learn about inner classes. Those are all members, which means you have to have an object in which to work with them. It's not just some random data on the wall somewhere. It's part of some object that was built from this class, and each class has their own version of that data. They all kind of use the same methods. Don't get me wrong. You can't change the behavior of a method. So, when I breathe and you breathe, it's fundamentally the same thing. We're just, our bodies individually, each object is doing the breathing, but the act of breathing is the same thing. But we each have our own name, we each have our own height and weight and eye color and all that stuff about us. All right, so that's the general structure of a class. It really, all we've talked about at this point is the name of the class, an open curly bracket, and a closed curly bracket. We'll fill in the rest of these blanks later on. Attributes, constructors, methods, we'll fill those in. But it's important that you understand that outside structure so that way you build it properly and are ready to go align the UML we've talked about to the elements we're going to fill in later on.